Copilot overview.
In this video, we provide an introduction to Copilot, an AI CAD assistant integrated directly. Copilot can help you with the following tasks. It can query into a large data set of documentation and find relative context. It can talk directly to your CAD data by extracting mathematical properties and attributes. And it can help identify anomalies and issues with your CAD data. We're going to go ahead and demonstrate some of these features today. Now, let's begin with showing a traditional way a designer would access documentation. So let's go ahead and bring up our user guide, and we're going to type in some keywords, and we'll do some keyword searching. We're going to search for solid from profiles. And then we'll click on it. Basically the keyword searching, you put your keywords in, it gives you a whole list of stuff, you examine the list, and then you pick the content and from the list. Another example, let's go to our YouTube channel, and let's do another keyword search. We'll type in solid modeling, and it'll find a list that we can then examine and pick and click what we want. Now let's see what we can do with an AI assistant. An AI assistant, we can ask it to tell us what tools are available for solid modeling and to provide any videos related to the tool. So in one click, we're going to go ahead and we're going to have it analyze all of our documentation, get the proper context to answer my screen, and provide any videos related to my question. Okay, so now it's found, what tools we have available in ViaCAD. We have solid primitives, profiles, booleans, features from solid utilities, local face, or direct edit modeling. And it's come up with a couple of videos. We can go ahead and click videos. Here's one that we have regarding how you can do threads in ViaCAD. Or here's a whole playlist associated with solid modeling that you can get. This is called RAG, Retrieval Augmented Generation, and it's a great first step for AI and CAD. Now, what's great about RAG is it can take a query or a concept and it can create a response that may not be obvious or what you could find with a simple word search approach. So I think that's very exciting for any experienced designer to learn and interact with a set of documentation that we didn't have before. Now, as one more example, let's ask Copilot to tell me something interesting about ViaCAD. So Copilot has reviewed the context, and it found the section on parent-child associativity as interesting. Now, if you use keyword searching through the user guide, nowhere are the words interesting and associativity mentioned together. Copilot has come up with something unique and different that I couldn't have found using traditional methods. This idea got me so excited that I wondered what would happen if I threw at the AI CAD data instead of user guides. What would it find interesting about a bunch of mathematical properties and attributes? I have at my disposal a very precise modeling kernel using Dassault ACES that can calculate and provide all kinds of properties ranging from derivatives, mass properties, continuities, lengths, areas, volumes. Well, it surprised me, leading to the next set of demonstrations. Now, let's see how Copilot works directly on my CAD data with my file. We're going to use the wrench file I used some years ago to demonstrate 3D printing of a single STL file with movable parts. First, let's get a summary of my file by typing in the following. Summarize the entities in my file for interesting properties. Okay, so it has examined my file and it has extracted out some metadata from our file properties attributes where I can get some comments about the file. I can actually, my metadata includes the actual video of the 3D printing. I can click on it and it'll play my video for me. It can also, it's reviewing all the entities I have in my part. I have a screw, it has some mass properties, density, material name, I have a handle, and I have a grip. And then there's some overall file properties. So that's interesting. It's just a really quick summary of what I have in my file. Let's go do something else now. I'm going to have it examine my file in detail for 3D printing to explain whether it passed or failed or if there are any warnings associated with any of my files. So let's go ahead and put in our question and hit apply. Okay, we received our results back from our question regarding 3D printing, and we can see that it provides us with a summary of each of the parts. There's 3 parts, and it tells us that the test that it passed includes it's a valid volume. There's no issues with the facets such as being duplicated or collapsed. It's closed and watertight. There's no non-manifold edges. It's a single component, and its normals are consistent with orientation. Same thing for the handle, and likewise for the grip. So this shows that it will pass the initial test for 3D printing. Alright, next up I want to ask it why I can't blend my part with a 0.6 inch blend. So let's go ahead and put it into the AI query and select my object and click apply. Okay, and it returns back and it tells us that it can't blend because of the tight curvature that exists in the file, and in fact the minimum radius of curvature is 0.46, implying that radial blends higher than that are going to fail. Now, one thing I want to do next is I ask it where the minimum radius of curvature occurs. So let's ask it that so I can get a location on my model to further understand the situation. Okay, so I'm just asking it where the minimum radius of curvature is for the selected entity. Okay, and it is telling us it is at this location, 9.2 minus 0.299.4. And if I create a little sphere at that point, that is this location right here. And you can see that that is a really tight turn in the model that is preventing larger blends. Lastly, just a few words about the state of AI as we look at some of the question answers we've used to test the Copilot so far. First, everything is rapidly changing. The underlying technology that we are using, consisting of machine learning libraries, large language models, system prompts, user prompts, embeddings, assistants, and agents, are rapidly changing and evolving. But some large issues remain that include 1. The need to improve accuracy. The response accuracy needs to get consistently better, especially in engineering where precision and accuracy matter. Much of this is dependent on LLM models' continued improvement. AI is an incredible assistant for an experienced engineer who has the ability to double-check the AI. However, for an inexperienced engineer, the results could be disastrous. Large language models need to follow system and user instructions better. I frequently see the large language model deviate from my instructions with what I call lazy responses. And finally, performance needs to improve. Currently, responses can take 15 plus seconds. For a designer exploring ideas, the AI needs to keep up without breaking up the thought process. And some final thoughts about my experiences so far. The integration of AI with CAD technology represents the most thrilling advancement in the field that I have encountered in decades. And we still need to explore text-to-CAD using scripting or image reconstruction during Sora. Reflecting on my journey since the early 80s, when I had the privilege of being part of a pioneering team at Lockheed that facilitated the transition of engineers from drafting boards to CAD, I cannot help but get excited at the impact this combination will have on engineering productivity. As a longtime CAD developer, it's exciting to be part of this next transformative stage in CAD. Thanks for watching. Stay tuned for more.
Thanks for watching.